In this video, you will learn how to calculate the mechanical advantage for a wheel and axle. The mechanical advantage for a wheel and axle system is calculated by dividing the radius of the effort by the radius of the load. You can see that in the equation below. We're going to apply that equation to solve a problem. The rudder of a large boat requires 400 pounds of force to turn the boat. The boat uses a wheel and axle system to provide mechanical advantage for the captain. The wheel has a diameter of 4 feet and the axle has a diameter of 6 inches. We need to calculate what is the mechanical advantage of this system, and then we need to calculate how much effort the captain must apply in order to turn the boat. To begin with, we start with a diagram. We're going to draw a wheel and axle that rotate together. In this case, the captain is applying his effort to the wheel. The load is going to be applied to the axle to move the rudder. In this case, it takes 400 pounds of force to move that rudder. We know that the wheel is 4 feet in diameter and that the axle is 6 inches in diameter. We need to convert this into a radius. We know that a 4-foot diameter is equal to 2 feet in a radius. We also know that a 6-inch diameter axle has a 3-inch radius. We need to convert 2 feet into 24 inches so that we're using similar units to solve the problem. The equation for mechanical advantage for a wheel and axle system is the radius of the effort divided by the radius of the load. We can apply our variables in this equation to solve the problem. In this case, the radius of our effort is 24 inches. The radius of our load is 3 inches. The inches cancel out, and we're left with a mechanical advantage of 8. We then need to calculate how much effort the captain needs to apply. In this case, we can plug in the variable of 400 pounds as our load to move the rudder. The mechanical advantage we just calculated was 8, and therefore the captain must apply 50 pounds of force to move the wheel in order to move the rudder for this boat. We're going to apply this equation differently to solve a different problem. In this case, the drivetrain on a truck applies 400 pounds of force to rotate the axle. The wheel and axle rotate together to provide propulsion for the truck. The wheel has a diameter of 2 feet and the axle has a diameter of 4 inches. What is the mechanical advantage of the system, and how much force can be applied to propel the truck? Again, we begin by diagramming the problem with a wheel and axle that rotate together. In this problem, the effort is applied to the axle from the drivetrain of the truck. The load is the propulsion that is driven from the wheel. We know that the drivetrain of the truck can apply 400 pounds of effort. We know that our wheel is 2 feet in diameter, and we know that our axle is 4 inches in diameter. We need to convert this into radius. A 4-inch diameter axle has a 2-inch radius, and a 2-foot diameter wheel has a 1-foot radius. We need to convert 1 foot into 12 inches so that we have similar units in solving our problem. The mechanical advantage for a wheel and axle system is equal to the radius of the effort divided by the radius of the load. We're going to apply these variables to solve this problem. In this case, the radius of the effort is 2 inches. This is from the axle, the radius of the axle. The radius of the load is 12 inches. Our inches cancel out, and we're left with a mechanical advantage of 0.16. Now we need to apply this to solve for load. We have to rearrange the effort equation so that effort is multiplied times the mechanical advantage to solve for load. In this case, we know that our effort is 400 pounds, our mechanical advantage is 0.16, and as a result, the propulsion force that the wheel can apply to the road to move the truck is 66.66 pounds.